Okay, we're recording. So we're doing the pages 4, 5, and 6 of the 4.2 notes. So here he has to find the slope of the curve where this is defined. Remember, the slope of the curve is the derivative. We know this. Or dy over dx. And one tip is that instead of finding where dy over dx is defined, find where dy over dx is undefined. Now, when is something undefined, or when does a fraction not exist? That's when your denominator equals 0. Sorry, I don't know why I'm congested. I'm not sick. That's when b equals 0. The bottom here. So what I'm going to do is I'm going to take this derivative, and I'm going to be, again, very deliberate with how I do it. D dx of the left side and d dx of the right side. Now, what's d dx of the right side? That's just 0. 0 to 16 is 0. On this side, little huge sigh, we're going to have to do a product rule twice. Product rule here. And product rule here. So I'm going to do this as two separate problems. So x squared y. If I do that product rule, that's deriv x squared times y plus x squared times deriv y. Well, that's going to be 2x times y plus x squared times 1 times dy over dx. Remember, we're doing it with y. In green, I'll do it in the lower right corner. That's xy squared. If I take that derivative, so do deriv x times y squared plus x times deriv y squared. So that's going to be 1 times y squared plus x times, now that's 2y times dy over dx. Now you got to bring those back up. So you're going to have 2xy plus x squared times dy over dx minus because it's a minus, right? Don't forget about that. Whatever deriv xy squared is, that's going to be y squared plus 2xy times dy over dx. Now, we have to isolate dy over dx. Now it's all algebra at this point, just so you know. It's all algebra. 2xy plus x squared times dy over dx minus y squared minus 2xy times dy over dx equals 0. I'll probably move these terms. Let me get a highlighter out. These terms here, I'll move to the right side. And I'm highlighting green, will stay on the left side. So what this means is that I have 2xy minus y squared equals 2xy times dy dx minus x squared times dy dx. So all those have to move over. You pull out the dy over dx. Two xy minus x squared. And of course, you have this. And then you divide out this over here. And let me erase the other stuff because now it's getting a little distracting. Let me erase all that in blue. Let me erase this stuff here in green. Let's focus on the red. So yeah, if I divide out 2xy minus x squared, I get 2xy minus y squared over 2xy minus x squared. Okay. So that's going to be my derivative. Before I go any further, because we do have to see where it's not defined, that's really what the question is asking. I mean, we have to see where it is defined, but let's find where it's not defined and then remove it from our final answer. But any questions that so far, like any of these lines or steps that you want me to re-explain? And again, this is recorded, so you could rewatch if you need to. But anywhere in this process that you guys wanted me to re-explain or no? Okay. So remember, again, you do derivative both sides. Derivative 16 0, that's easy. The derivative left side let out the huge sigh, like we had to do product rule twice. So when I did derivative x squared y, I took derivative x squared, which is 2x times y, then plus x squared times derivative y, which is dy over dx. And I did it again for xy squared, which is that. And there's a minus to show the minus. And then you have two terms of dy dx. You got to collect the term dy over dx. Move over to another side. Ones that didn't have dy over dx, keep it on the other side. And again, you kind of work it all out, blah, blah, blah. Okay, so now, where is it not defined? You're not going to be defined when a fraction is 0. Sorry, when the denominator of a fraction is 0, right? So let's use purple here. So 2xy minus x squared equals 0. We don't want that happening for us, right? And that's a little funky, a little strange. But if you think about it, let's pull out an x here. So of course, when x equals 0, that's going to be true. Or when 2y minus x equals 0. Or when x equals 2y. Okay, so definitely when x is 0. The problem is that when x is 0, that's not going to lead us to anything. Because now what I'm going to do, let me use the left side here, left margin. Let me erase the stuff. And it looks like there's a question in the chat. Could you please go over the product rule step again, explain where you put dy over dx? Yeah, so the product rule step again. One more time. It's right here. So x, that's not a good color. Let's just do black. X squared y. So when I do the product rule right, you take derivative x squared, which is 2x, and leave it alone to the second one, plus x squared times derivative y, which is 1, but times dy over dx. And so that's where the dy over dx goes, where you take derivative y. So that's how you got that part over here. And then you should repeat that for xy squared. Okay, so now again, you're asked to find where this derivative is not defined. It's obviously not defined when the bottom is 0. So I set the bottom equal to 0, did a little factoring, and realized okay, x equals 0 or 2y minus x equals 0. If 2y minus x equals 0, then 2y equals x. Now, if x equals 0, if that in fact is true, there's a problem. 0 squared times y minus 0 times y squared equals 16. Everything goes away, leading to a statement that's not true. So x isn't equal 0 on the curve anyway. So we don't have to worry about that. So you can ignore that part. But x equals 2y, let's substitute. If x equals 2y, I replace x with 2y. 2y squared times y minus 2y times y squared equals 16. Well, if I factor 2y, if I square 2y, that's 4y squared, but then 4y cubed minus 2y cubed. 2y cubed equals 16. Y cubed is 8. Y is 2. And if y is 2, then x is going to be 4. So what this tells me is that the slope is defined everywhere except 4, 4, 2. Defined everywhere. Sorry, I can write better than that. Except at 4, 2. And so if you were to actually graph this, and let's actually do in Desmos, the nice thing about Desmos is that you can just type in as is and it'll graph it for you. So let's actually type in x squared y minus x y squared equals 16. I'm going to clear this. I could undo it if you guys need me to. But I'm going to go to Desmos right now. So xy squared. I already forgot the equation. What is it? X squared y, see? X squared y minus xy squared. I forget things easily. X squared y. Let's try again. X squared y. Oh, goodness. X squared y. Sorry for being a little sluggish here. Equals 16. So he actually graphs it for you, which is really nice. This is the beauty about Desmos. And at 4, 2, you're going to see that there's probably going to be a vertical tangent there. What's the slope of vertical lines? Undefined. Therefore, your drift's not going to be defined there, right? And that's going to be the only place where that happens. You have a vertical tangent. So I feel good about my answer for that reason. So Desmos is a great way to verify your work. We're not done the TI-84 calculator because you have to isolate y, and that's a little that would have been actually it's impossible to do for this problem. So that's that one. Now, where can you find horizontal tangent? Well, of course, when dy over dx is 0, or the numerator is 0. I already forgot the answer, so I'm just going to pull up the completed notes. Yeah, so basically wherever you would set that equal to 0. And then you see where you have horizontal tangents, if there are any. And actually, looking at this graph, yeah, it looks like there would be one at -2, -4. And I guess that would make the numerator 0. Okay, any questions before we move on to the other parts of these notes? Nope, okay. The rest should go by pretty quickly after I finish example 6. And then I'll give you guys a little chance to do some practice. And then we'll do the quiz. Okay, so example 6. So you have this right here. So again, and you're asked to find the second second derivative. And one strategic tip, I'll come back to that tip a little later. I'm not sure when we'll need that, but I think maybe after the first rib we'll need a strategic tip. Let's just do this first. So you see why we have different notation, right? Like d over dx, that just, makes this process a little easier to do. So if I work this out, that's going to be 2y, but you got to say times dy over dx, plus 2, but you got to say dy over dx. Then here, derivative 2x is just 2. And you don't have to, I mean, you say dx or dx, but that's redundant, so just get rid of it. And derivative 1, of course, is 0. And anything times 0 is 0, right? So let's isolate dy over dx. You factor it out. You have 2y plus 2. And divide everything by 2y plus 2. And by the way, we could actually pull out 2 from the bottom. And those cancel, so I get 1 over y plus 1. So there's my first derivative. My first derivative is 1 over y plus 1. However, I'm not done yet. Now I want the second derivative. Before I do the second derivative, are there any questions? Because I'll need to clear the screen. Nope, okay. So hopefully you're seeing the process again. Anything that has y in it, you got to put that dy over dx. By the way, sometimes I get a little lazy. I will do this. And then you're isolating y prime, because y prime dy over dx are the same thing. It's just better to write dy over dx, so you're being mindful of what you're taking with respect to x. So it's just being a little more deliberate. But once you get the hang of it, if you want to write y prime and that you isolate y prime, have at it. Totally fine. Okay, so 1 over y plus 1, that was my first derivative. Or dy over dx. Now what you're going to do is you're going to do the derivative again. So I'm going to do d dx here and d dx here. Now, when you do d dx, dy over dx, that becomes a second derivative. So we write like this, d2y over dx squared. It's kind of like these two d's here are being multiplied. The dx times dx is kind of strange. Like, why not write it as d2 times x2? I don't know. I guess this just indicates that you're doing the derivative with x with respect to x twice. So anyway, that's just notation, just so you know. This means double derivative. If you want to write double derivative, that's fine too, with the 2 accent marks. Or it looks like a quotation mark, I suppose. Now, this is where the strategic tip comes into play. If you have a constant over f of x, like say 1 over y plus 1, which is what we have right now, or anything like that, yes, we have y plus 1, it's not in terms of x, but regardless, you have 1 over an expression, you can rewrite it as 1 or the constant times the expression raised to negative 1 power. So I could write this, before I get too carried away here, I could have actually done this instead. Y plus 1 raised to negative 1 power. Same thing. And then what I'm going to be doing is I'll be doing kind of like a power / chain rule kind of thing, instead of a quotient rule. You can do quotient rule if you want. I don't care. But this might be a little easier if you did it this way. So there's a question in the chat. Yes, if the numerator was not a constant, yes, then you have to use quotient rule. Like if I had like y plus 1 cubed, or sorry, if I had something really weird, like say x squared over y plus 1, yeah, I had to use quotient. I had no choice. Well, actually, no, I do have a choice. I can do this. Then I do product rule, but then chain rule. But I think that's the same amount of work either way. So I'll leave it up to you to decide. But if it's a constant, you can just do it like this instead. Okay, so we have d2 y over dx squared equals, move that negative 1 to the front, y plus 1 raised to negative 2 power times the derivative of the inside. Notice I haven't done the dy over dx yet, because I haven't taken the derivative of y yet, but I'm about to. I'm going to get like kind of lazy and just do this. I'm just repeating the previous step. That's negative 1 over y plus 1 squared, of course. Oh, come on. And the derivative of this, derivative of y is going to be 1, but you got to say dy over dx. And derivative of 1 is 0, so you put 0. Now, this is the fun part. What did dy over dx equal in the previous in our previous work? 1 over y plus 1. So I'm going to replace dy over dx with 1 over y plus 1, because that's what it was from our previous step. And final answer is -1. Just go back to red, sorry. Don't want to confuse you guys. So final answer is going to be -1 over y plus 1 cubed. This is definitely a little bit more advanced of an implicit differentiation problem. This is something that the College Board has done lately on the AP exam. Regardless if it's in person or on the internet, which they did last year or last school year, I'm almost certain they're going to ask this question. I would bet serious money this question is asked because you really want to make sure that you really know your implicit differentiation. You know your notation. You know how to substitute correctly. You understand that dy over dx was more y plus 1 from a previous step. So this is an extremely involved process. I'm glad I'm recording this. I would strongly recommend you rewatch it if you need to. So that's what's happening there. In interest of time, let me keep moving. If you have any questions about what I just did here, you can find me during office. I'm actually doing 2 office hours tomorrow. I'm doing one in the morning, and I'm also doing one in the afternoon at 2 o'clock. And I'm also doing office hours on Monday and Wednesday as well at 2 o'clock. And I'm also doing office hours on Tuesday, Wednesday, and Thursday, also my normal 8:15 a.m. time slot. So there's plenty of opportunities to talk to me if you need extra support. Here, all this is just saying is the power rule applies to any exponent. So as long as n is a rational number, just do the power rule. Like that's just 1/2 times x to -1/2. That's just going to be 7 times 2/7 times x to -5/7. I suppose our assumption when we did power rule previously was that you had integers or non-integers. I kind of just didn't really care for that and just told you just do it for any real number. So don't really think anything of this. You're just doing what we've been doing all along. Just so you know. You could simplify afterwards, of course. I mean, if you simplify, easy. Those cancel, those cancel, those cancel, but I don't really care. So that's all that's going on there. There's a formal proof that goes with it, which actually I may have forgotten. Excuse me. So I'll do that form proof in just a little bit. But if we look at this one here, y prime, well, let's do this first. So you're gonna move that 1/4 to the front. Three x to the 2/3 plus 5 raised to -5/4. And then times the derivative of the inside. So it's negative. And then times the derivative of that's going to be 3 times 2/3 times x to -1/3 plus 0. Those cancel. Times, and there you go. It's all the same stuff we've been doing previously. I just got to pull up my notes for that proof really quickly. Give me 1 sec. And then actually, we'll hold off on any homework review. We'll save that for next Tuesday in the interest of time. I want you guys to do a little practice when we start the quiz. But let me just do this form of proof with you guys. One sec here. So I don't quite remember it off the top of my head. I can figure it out, but I don't want to botch it. There I fill out notes. Oh, it's not even filled out. We'll save that for next week. How about that? Okay. So we'll save that form of proof for next week. So next week, what we'll do on Tuesday, let me go ahead and clear my screen here. I'll work out a form of proof at home or in my free time, and that's what I do on Friday nights, Saturday nights. I just do calculus proofs. No, just kidding. Too busy watching a Netflix show right now. That's why I've been up late. Queen's Gambit, by the way, that's the show I've been watching, in case anyone's curious. Actually, what did you guys say? Interesting. Great British Baking Show. Yes, I am watching that, but not binge watching it. British Baking Show, just so you know, they release a new one every Friday, so they space it out. So you can't really binge. You can binge watch an old stuff, I guess, but that's not really my cup of tea. Yeah, Queen's Gambit. I started episode 4. It was like 1 in the morning. Okay, I gotta go to sleep. The Office. I never really got into The Office, to be honest with you. I know it's a great show. Don't get me wrong. Chappelle's Show, I did watch that religiously about 15 years ago when I was on Comedy Central. I still watch sketches on YouTube from time to time if I just need a good chuckle. Really clever stuff. But yeah, it's Queen's Gambit. That's a really great show. Done really, really well. Great character development. I'd say it's probably up there in my top 5 Netflix shows of all time. Just in case you know, one of my other favorite shows, Ozark. If you guys want to watch Ozark, that's a great show too. Very violent, but done extremely well. Anyway, not talking about Netflix though. So what I'd like you guys to do for maybe about 10, we'll say maybe 13 minutes, 12 minutes, we'll say. I want you guys to do these problems in the breakout rooms. So if you go to Schoology, you'll see this chain rule worksheet November 12th and table derivatives worksheet Thursday, November 12th. Now for the first one, I would strongly urge you to start with number 9 on the chain rule worksheet November 12th. Start with number 9, and the answer is obviously shown down here, and they actually show the steps. And then try maybe number 10 after that. Then I would then go to the table derivatives, the other worksheet. You have a table here. And I would probably maybe do A just to make sure you're comfortable using the table, and then do D as in dog. So again, I would strongly suggest that you start with number 9 and 10 of the first worksheet. Again, these are in Schoology. You don't have to download or print them. You can just open it up and just do it on a piece of paper just so you can view it. And then table derivatives do A and D. So 9, 10, and then A and D on the table derivatives. We'll do this for about 12, but it's like 10 minutes. We'll come back, and then we'll start the quiz. And I'll actually upload the quiz to Schoology right before the breakout session's over. So, and then you guys can download it and print it and, of course, work that out. But yeah, I think that is pretty much it. So cool. I'll have you guys go to breakout rooms right now. And there's a question in the chats. What's the question in the chats? No, they don't have to be simplified. I don't care. Not at all. All right. So let me stop.